Okay everyone, in our third example, we look at a different question type. You notice that we have a graph that undergoes 4 transformations and they give you the resulting graph, wanting you to determine the original graph. So the technique is quite clear. They give you the resultant, they give you the process, they want you to find the start. You just need to work backwards. Alright, so we have y equals to fx becoming y equals to 2 ln 2x minus 6. So we start off with that, right? Because you're going to work backwards, let's start with the end. Y equals to 2 ln 2x minus 6. Alright, so the first, or rather the last transformation that the graph went through was a scaling parallel to the y-axis with scale factor 2. Alright, so one way to do it is this. Alright, we know that it's y equals to fx, so if it's a scale parallel to y-axis, you multiply the equation by times 2. As such, to reverse this times 2, you now do divided by 2. Alright, so what you can do is y equals to 2 ln x, 2x minus 6, what we can write is before 4, you had y equals to ln 2x minus 6. Alright, okay, so obviously you can do it the other way around. Instead of looking at times y divided by 2, if I look at the more general state, you know that you had y becoming half y. That means you have half y here. It means you now need to multiply by 2. So if you have y at the end, it was under half y, you need to multiply by 2 to give you 2y back. Alright, the ratio kind of must be the same. So that's one way to think of it, but because you're doing y equals to fx, I like to do it this way around. A translation of 3 units in the positive x direction. Alright, direction of the positive x-axis has the same meaning. So before 3, now 3 units in the positive x-axis means that you have x becoming x minus 3. So if you have every variable minus 3, now you just need to plus back 3. As such, you have y equals to ln 2x plus 3. Alright, don't forget you're dealing with the variable itself. Don't forget that the variable is also affected by the scaling. Alright, so bracket x plus 3 minus 6, it actually gives you simply ln 2x. Okay, now a reflection about the y-axis. So you know what a reflection about the y-axis does, right? It basically transforms your x to minus x. So now before 2, we just simply perform the same thing. You reverse the minus, which is basically just reflect back again, we're just applying a minus as well. Alright, so we get y equals to ln minus 2x. Now the last transformation, which is a scale parallel to the x-axis with scale factor 1.5, aka 3 over 2, which means if you think about it, how you actually transform, right? You apply every x value with the factor 2 over 3, right? So you times every x value with 2 over 3, which means now you need to times every factor by 3 over 2. Basically, divide by 2 over 3 equals to 3 over 2. As such, we just multiply by 3 over 2 because we're doing the reverse, which we now have minus 3x. Alright, so and this is the original graph, right? Determine y equals to fx, we then have fx equals to ln minus 3x. Okay, so there we have it, basically just reversing every transformation. So I repeat, from 4 to 1, we reverse 4, you divide by 2 because you multiply your y value by 2, you have to divide by 2. Translate 3 in the positive x-axis means that you have x to x minus 3, you now need to plus back the 3. Reflection by y-axis, x become minus x, reverse it, it's the same thing, right? You just reflect back the axis, which is again applying the minus sign as well. Scale parallel to x-axis, where you would multiply by 2 over 3, which means to reverse it, you must multiply by 3 over 2, or divide by 2/3, which is the same thing as multiply by 3 over 2. Alright, so there we have it, the reverse and working backwards.